All right, so I have Mayank Kejriwal. He is a research assistant professor at the USC Information Sciences Institute. Welcome to the Data Exchange podcast.
Thank you. Glad to be here.
So I've been looking forward to talking with you because you are an expert in knowledge graphs, a topic I am somewhat familiar with, but really not an expert or not a frequent user of. So, first of all, what exactly are knowledge graphs?
So, knowledge graphs are a way to get knowledge into a machine. And here I want to talk a little bit about what knowledge is. So, knowledge is not the zeros and ones that we associate with information, it is not raw data like strings that we see in code and in documents and so on. But knowledge should be thought about as the body of information in our brains, in the human brain, that is the backbone of intelligence. So think about how we humans have a lot of knowledge, right? We go around our daily lives, we know people, we work in our jobs, so we have a lot of expert knowledge about the things that we do. But we also have knowledge about social relations. We have knowledge about other things. We may have a special skill, so that's a kind of knowledge. So we want to actually get machines to have that kind of knowledge, and that is not zeros and ones. There is something deeper to it because we can use the knowledge in very robust ways. We can reason about it, we can imagine, we can do all kinds of things with it, and we want the machine to have the same capability. So a knowledge graph is a model for getting that kind of knowledge into a machine and for facilitating AI applications that use that knowledge.
So, quick question. So, you hinted at zeros and ones, which is like information. So, if they're not, if knowledge is different from information, so is knowledge represented in kind of these RDF triples? Is that how people represent knowledge?
No, I think the RDF triples are also zeros and ones if you think about it, because
Right.
they are it's like a database, right? So even if you have a database inside a machine, I mean, if you just go drill down deep enough, it's still zeros and ones. It's not different. I think I want to give the analogy over here. In our brain, right? We don't actually have a neuron, or at least as far as I know, we don't have a neuron for our mother and our father and everyone else. I mean, in our brain, it's all just electrical signals, right? So we have these biological entities in our brain, and there are electrical signals that are going around in our brain. So it's if you drill down deep enough, then it kind of becomes like zeros and ones, even in our brain, right? There is a very low level representation that is happening biologically. Similarly, in a machine, we have the zeros and ones. That is the low level representation. But there has to be something more than that. We have to build layers on top of that, and we can use database, we can use RDF, we can use NoSQL. I think all of those are choices. There's no one right choice, it turns out. But what we really need to do, I think, that to make a model successful, we need to show that that the machine is able to reason about the knowledge in a way that, and I use the word reason here in a very not in a formal way, but the way that we humans reason. So the machine should be able to reason about the knowledge and do things with the knowledge in the same way that we would expect an intelligent agent to do, like a human. And that's the criteria for success. Yeah.
So let me ask you. So we'll get into the AI and the reasoning aspect shortly, but some basic things. So knowledge. There's two kind of things that come up when you talk about knowledge systems. So knowledge graphs, knowledge bases. So the
Yeah.
first one communicates that you're storing it in a graph database. The second one, knowledge base, seems like it might be stored in a more traditional database system. But in both cases, it seems to me that one of your goals is to be able to query and ask questions, right?
Correct. In fact, search is one of the predominant reasons why knowledge graphs came into existence. So I want to say that just because it's a knowledge graph doesn't mean that we store it in a graph database. A graph is a very fundamental mathematical object, and the best example I can give you is a social network. So in a social network, So a graph is a collection of nodes and edges. Now in a social network, the nodes are people in the most simple social network, right? The nodes are people. The links are, the edges are links between the people, right? Expressing some relationship. Usually it's friendship, right? In an internet social network. But we have very rich social networks now, right? So on the LinkedIn network, you don't just have people, you have groups, you have organizations, you have clubs, you have all kinds of things happening. And then you have very rich kind of relations. So I can follow you, that is one kind of relation. I can be your connection, that is another kind of relation. And notice how the relations have directions. So I can follow you, but you don't have to follow me. So that is what we call an asymmetric relation. It's a directed relation. But if I'm connected to you, then that doesn't have a direction. If I'm connected to you, you are connected to me. That's the way things work, right? On LinkedIn. Similarly, if we are friends on Facebook, it's not that you are my friend and I am not your friend. It goes in both directions. So this is what we call undirected. So this kind of shows you how rich the relations can be. They can have directions, they can have labels, they can have types. And so a knowledge graph is really, it's like that. You have nodes of different types, you have relations of different types, they all have edges, they all have labels on them, and that is the abstract model. Now that abstract model, you can draw it out on paper, you can put it in a graph database, you can put it in a NoSQL database like Elasticsearch, many people do that. You can even put it in a relational database. It turns out it's even possible to do that. So it's
Mayank, the graph database people will object because they will say in a graph databases are optimized for the types of questions and queries you would ask. By the way, before you answer that question, let me make this concrete. So I take Wikipedia.
Yes.
Right. So a lot of people I think who work in this field take Wikipedia, and that's kind of the canonical data set to try out things. So how do I go from Wikipedia to a knowledge graph? So Wikipedia is a bunch of articles.
Correct.
Okay.
So I would recommend not starting with Wikipedia, but starting with either Wikidata or DBpedia. So those are two data sets, among others, that are derived from Wikipedia. So they contain the same information, they contain a subset of information, let's say. At least DBpedia does. DBpedia contains a subset of information in Wikipedia, specifically the info boxes, right? So when you go to a Wikipedia page, there is something on the side, it's a box, right, which contains, like if you go to President Barack Obama's Wikipedia page, you'll see that, okay, there's the name, there's the, other things in the box, right? It's like a calling card. And DBpedia extracts that information and has already built a kind of a knowledge graph. So, and it's available for download. Wikidata is independent from Wikipedia, it turns out. There are links to Wikipedia, but it's actually independent. It's like a crowdsourced knowledge graph, just like Wikipedia is a crowdsourced encyclopedia. But I recommend starting with those because those are already in graph format. And what I mean by that is it's not that they are in a graph database, but they are in a graph. They are graphs. So if you download them, then you can get them as graphs and then you can play with them. I will say that for the graph database people, if they can prove to me and to everyone else that they can run faster than a relational database for in the general case, or they can run faster than Lucene for information retrieval, then I will agree with them. I don't think they can do that. And so a lot of people do have queries that actually can be very well served by Lucene, depending on whether they have a lot of text and IR, or they have very relational database-like queries. They can express their queries in SQL, and so if you can put your knowledge graph in SQL, and that is trickier. We have seen fewer examples of that. But its speed is very important. When you're querying, speed is very important. Google is not using a graph database, to our knowledge, right?
So you have knowledge graph, and so you threw out other terms there, but so what's the relationship between knowledge graph as we know it and knowledge graph as the term that Google uses?
I don't think there's a big difference. In fact, the modern meaning of knowledge graph is inspired a lot by Google, because even though graphs have existed and knowledge bases have existed in the AI community, both in academia and industry for many decades past, going back all the way to the early 90s and even before. Google was the one who really popularized and launched, I would say, the modern knowledge graph concept, because in 2011, there was a blog post by a Google VP that was called Things Not Strings. And I think that expresses it beautifully. Strings are the information, the data, right, that we had started the conversation with. And things are the things that are in our mind, the entities, the people, the organization. That's not just raw data. We have very strong intuitions about when we deal with people, we have a certain model in our minds that implies something, right? It's not just zeros and ones to us. So Google was trying to convert strings to things, so that when you search for, let's say, places to visit in Los Angeles, you don't just see a ranked list of web pages. That's what it used to be like, right? Now you see the beauty of treating search and people's intent as things and not strings, because you would literally see the places to visit in Los Angeles at the top of the screen. When you search for movies, like thriller movies, you would actually see the list of movies at the top of the web page. You don't even need to click on something. Right on the top of the page, if you do it on Google right now, you will see that it comes up. It's like Google can understand that thriller movies is a thing, is a set of things. Places to visit in Los Angeles is a set of things. If you search for Leonardo da Vinci, you will see the knowledge panel crop up on the side. Google recognizes that that's a thing. It is not just a set of characters that are bundled together, but it's Leonardo da Vinci is a thing and has an entry in Wikipedia and also in the Google Knowledge Graph, and it shows you the panel, and it also shows you other things. What are people searching for besides Leonardo? What is the core information about Leonardo? It will show you that on the knowledge panel. So it's really revolutionized search. There's no question about it. And even today, I would say that is the central application. It is search. But there are other applications that have come up around it, like recommendation and other things. But there is a very strong connection to search. Even in those applications, they have been inspired by search as well. So it's information retrieval and search continues to be a very strong application of knowledge graphs.
So I'm in a company and I'm listening to this podcast. What would you say to someone who's a very skilled data scientist, wants to get their feet wet a little bit on knowledge graph? So what are some ways for them to try it and to possibly convince their management to pursue it further?
Yes. So I think that if your company has a lot of data sets, right, that would be data integration would be a very strong enterprise motivation. I'm assuming that you're not a traditional search company, but you may still have search needs, right? So you may have a recommender system, or you may have a website that you're trying to improve through having a better search experience. You might be an e-commerce company. E-commerce has been a huge user of knowledge graph. The Amazon product graph is the best example. They have really grown their knowledge graph by leaps and bounds. They have an entire team dealing with it. So if you have like search, then that is one very good application. But if other than that, if you just want to do data integration, if you have a lot of data sets lying around, then, what are your options, right? One option is that you build some ad hoc system, which is, I don't think you will have buy-in for that. It will require an entire team. The second use case is that you invest in a heavy RDB system, relational database system, and that's expensive, and it's not clear that that's suitable for heterogeneous data sets. Some of it is a lot of text, some of it is structured, there's missing attributes, tables with lots of missing cells, log files, etc. So in that kind of situation, I think you want to show that the knowledge graph can be a very good way of bringing together all the data sets. And so one way that you can begin is to take samples of some of these data sets and build a proof of concept knowledge graph by showing how you can actually do the data integration by using a knowledge graph, by representing these different data sets as graphs. And it does require some work. So there's no one magic tool. Just like in AI, there's, if you're trying to do deep learning, right, there's no magic tool that will actually do all the deep learning for you. You still have to design the model. You still have to make sure that the data is input in the right way. And then, TensorFlow and other tools like that will make it easy for you. So you don't have to code the model from scratch. But it's not like you can just tell TensorFlow that, hey, TensorFlow, do deep learning on my data set. and it doesn't do that, right? You still have to do some work before that happens. So that is how I would begin. And there are lots of free tools out there. I mean, if you have a lot of natural language data, then Spacey and NLTK, and among others, but I really like to point out Spacey and NLTK because I've worked with them. They can help you. They have pre-trained models. You don't have to do any training. They can extract all the common entities from your data set. If you want to train them, you can even train them on the entities of your choice. If you have entities that are well known, so they are not just specific to your company, but they are things like places, for example, right? So if you have locations in your data set, then you can link them to geo names, right? Which is a common knowledge graph. It's available. It's also a knowledge base, but it has all the information you could want on places, right? You could link it to that, and that enriches your data set. So there are 2-3 directions. One direction is that you first try to do the data integration. Second direction is you can do information extraction. That is more NLP oriented. Third use case is that you can try to link entities and data sets to external open source data sets, right? So you can download them, bring them in, and then try to link to that. And then finally, visualization, search, recommendation, all of that can be supported by using these kinds of knowledge graphs. So that I think is very important because you want to keep your eye on the application. So you want to think about an application and go from there rather than from the bottom up and then try to find the application.
So what are, to your mind, Mayank, what are some of the publicly known famous recommender systems that rely on knowledge graphs?
I think e-commerce is the best one I like to use because I've worked with e-commerce companies or media companies. In my collaboration, I have some collaboration ongoing right now, in fact, on that. But I'm very familiar with that community. And so I can tell you that Amazon and several other companies, but I'm most familiar with Amazon because they have been very proactive in the community. Their researchers have gone to the top conferences and presented on this. So it's not a secret that the Amazon product graph has really been a very major movement, I think, inside Amazon, as far as I can see. And
so let's make this concrete. So I search for a product on Amazon.
Yes.
It takes the search engine takes the string, and then what happens?
So I'm not privy to all the internal details. So this is hypothetical.
Yeah.
I'm not speaking for Amazon. I've never worked for Amazon. But I think when you search for a product, as I understand it, just like the Google knowledge graph, when you search for something on Google, it can bring up the knowledge panel. It can associate your search with entities in the knowledge graph and then present the search results a certain way. I think that when you search on Amazon, if it can link your product to an actual product in the product graph,
then it surfaces that panel.
It can surface that, but it also knows what you're searching for, right? Because that product is linked to other products. And that could be very helpful. So we know that recommendations are very important, right? So when you're searching for a product on Amazon and then you go to the product page, the recommendations are at the bottom. So I don't know about the average user, but I certainly pay a lot of attention to those because sometimes what happens is that I see something in that recommendation that is better than what I'm looking at. So sometimes, you want that exact product, maybe you want the Apple earbuds and you won't settle for anything else. But at other times, let's say you're doing grocery shopping and you're searching for a simmer sauce, right? So I use simmer sauce a lot, being Indian, I love to cook Indian dishes and simmer sauces. I can't make my own, that's too much. So I'll search for a simmer sauce, something will come up, I'll click on it. And then at the bottom, I'll see all these recommendations of other simmer sauces or other things that I wasn't aware of, right? And then that might lead me to another product, and then I might end up buying more or buying a more expensive product because it's good. I didn't know it existed, right? So I think those are all the use cases, better recommendations, making sure that the user finds what they are looking for very quickly. Those are all the standard use cases. It's not unique to Amazon, but certainly we know that by having the product graph, searches on Amazon have become very good. Again, I'm speaking from my own experience, but I do know that searches on Amazon, I can find what I'm looking for very quickly compared to some other websites. And the second thing is Alexa, right? We can never forget Alexa. So that is another use case, very big use case. The conversational agents, right? Alexa and Siri, both to my knowledge that I have, again, not privy to the internal workings and I have not worked for these companies, Apple and Amazon, but I do know from my from my industry knowledge in general, from talking to the researchers, from looking at what they've presented in public, I do know that there is a knowledge graph in both Apple as well as in Amazon that they are trying to use, or in some capacity they are using, and for conversational chatbots. How deep the use is, I don't know. Yeah.
So Mayank, you mentioned a couple of things in the course of the conversation, actual knowledge bases and knowledge graphs,
Yes.
Wikipedia and Geopedia. So it's one piece of advice to our listeners then is to find existing knowledge bases and
Yes.
figure out how to hook up to them, right? So
I think so. I think it's like a hello world, right? Like when you do programming, like you don't want to start with your data set. Like let's say you're trying to do sentiment analysis or you want to do machine learning. Like usually the way you learn is that you go to the UCI machine learning repository, or Kaggle or some other place. There are many data sets, right? You download them, you play with them, you become familiar, you know what to expect. And then you start doing on more experimental data sets, more experiment models. Same thing over here, like with any new technology. There are lots of open knowledge graphs available. You can use the whole thing, which is big. You can also use subsets of them. There are samples available. There's plenty. There's so many knowledge graphs publicly available now. It's really great to see it.
So is there pretty much a knowledge graph in most domains?
I don't want to say most domains, but certainly the big ones there are. So we can, in industry, I can tell you that media, so the media companies have looked at, I don't think they call it a knowledge graph, but it's what they use is similar. The big companies like the New York Times has been a proponent. I think they certainly have an ontology, which we are aware of.
Is IMDb a knowledge graph?
I would say it's a knowledge base. It's not, but the difference between a knowledge base and a knowledge graph has actually disappeared. I think that most knowledge bases are knowledge graphs. Because traditionally what used to happen was, I'll tell you why the difference arose in the first place. The knowledge base is a much older term. And it arose because people were representing, facts. Like let's say you have a movie, right? So a movie has an actor. So the fact that this person is an actor in this movie, which is there in IMDb, right? That would literally be like a triple, what we call a triple. It's a fact. It exists in your knowledge base. But over time, as these knowledge bases grew very big, they have become graphs because you don't have just one actor. The actor is acting in multiple movies. The movie has multiple actors. The movie has a director. The director directed other movies. So there are lots of connections now, right? So it's become like a graph. So every knowledge base that I'm aware of is also a knowledge graph. So yes, the long answer is yes. The short answer is yes.
That's the Kevin Bacon 6 degrees of separation, right?
Not quite. I'm happy you brought that up. I think that shows up more in social networks.
Okay.
But you're right that it's related. It's related that now we have so much data. I think there is so much data that the 6 degrees of separation, I wouldn't say it holds in knowledge graphs, but certainly there's a lot of connectivity now, which was not there before. Previously, it was all isolated. Like you would have a few facts about this, a few facts about that, and nothing was too connected. But now, because of the internet, I think everything has become very connected, and you can find some kind of connection. You can pick 2 random entities in the world, and I think you can find some connection, some sequence of connections that leads from one to the other.
Let me ask you about the recommender. So let's say I have an existing recommender, which is doing okay.
Mm-hmm.
And then I realize, there's a relevant knowledge graph I can hook up to. I think in my mind, it's obvious that if I hook up to the knowledge graph, the recommender is not going to do worse. It's at least going to do as well, probably. And it probably will do better. So when exactly did people in recommendation systems start getting into knowledge graphs?
I think it was domain by domain. So we know that in the social networks, they have something that looks like a knowledge graph. And the social networks are very interested in recommendation. Obviously, it depends. You have to recommend good things and good advertisements and so on. Because we know that the Open Graph Protocol, right? Like a lot of the data that is published using Open Graph Protocol, also schema.org, those things are now looking more and more like knowledge graphs, right? And in LinkedIn has a proper knowledge graph. It's called the LinkedIn graph. and Microsoft bought LinkedIn, right? And so Microsoft will also has Bing, so they were also working on knowledge graph. So there's and then I don't know too much about Netflix, but certainly for Amazon, as I was saying, they are using knowledge graph, a kind of knowledge graph for various tasks, as far as I know.
By the way, you
Google has
mentioned
Google Knowledge Graph. It also has Google Shopping, Google Books, and so on. It's hard to imagine that they're not using it, right? So there is, all I can tell you is that it's gone application by application. It's not like the community just woke up one day and said, we're going to start using this. I think it went application by application. They saw that this is a great way to both to get more data, to find connections that didn't exist before, and also for machine learning, because I would actually push back a little on what you said, which is that if I link it to a knowledge graph, the performance will not go down. If you link it in the wrong way or you link it to the wrong knowledge graph, the performance could go down. So you have to be careful about what you link it to and how you use it. I think that's very important.
No, I'm just I'm speaking optimistically.
Yes.
Right.
I think if it's optimistic, the performance would go up by leaps and bounds. So no argument from me there.
So, couple of questions. First is my friend Chris Ray up here in Stanford has had a couple of open source projects.
Yes.
The first one was called Deep Dive.
I'm very familiar with it.
Yeah, and then the second one is Snorkel. So, yes. In my mind, they're the way I think of them is mostly for information extraction. Is that?
Yes.
Yeah. So which is a precursor, right? So if you're going to build a knowledge graph, you have to do that first, right?
Correct.
Yeah.
Yeah, I mean, not necessarily, but it's pretty much the norm. And I think the reason is that a lot of the raw data is natural language, right? So when the raw data is text or natural language, and that is the case with Google, for example, right? Where they're looking at web pages. And so that's, a lot of it is natural language. But, not always, because like if you look at DBpedia, right? They got it from Wikipedia infoboxes, and the Wikipedia infoboxes are manually, like people had already gone in and had declared that those extractions inside the main text, the key extractions, were manually already put into the infobox by the crowdsourced, the people who are contributing to Wikipedia, right? Similarly, in Wikidata, that's a crowdsourced knowledge graph. So it's not, that doesn't come from extractions. People have, it's a crowdsourced knowledge graph. People go and directly put facts into it. Now, there's also text in it, so it can be hybrid. But all I'm saying is it's not necessarily. However, in most real cases, I think that you're usually working with text data. And so when you're working with text data, then the information extraction, what we call knowledge graph construction, KGC, knowledge graph construction, is an extremely important task. You have to do information extraction, and not just that, but you might have to do co-reference resolution. This is when the same extraction shows up both in the same document as well as in different documents. You might have Professor Kejriwal, you might have Mayank Kejriwal, you might have Mayank somewhere else, right? And then how do you know these are the same people? Just because they look the same doesn't mean that we are the same. There are other Mayanks, right?
Entity resolution.
That, I mean, it's very related to co-reference resolution. So co-reference happens when you try to do it at the extraction step. So you have the context around the word, right? You have some clues around the word. That usually they refer to that if you do it that way at sort of the very beginning. And when you also do it with pronouns, right? That's when it's like co-reference resolution. But once you have a raw graph, one way to do it is, because of scale, a lot of times, that, let's extract everything from the document, right? We'll do some co-reference resolution within the document, but then we have a graph, right? And then we have another graph, and across, let's say millions of documents, so you have these fragments that all have these connections to one another. I think when you get that raw graph that has been initially constructed, but has a lot of duplicates, also has a lot of erroneous links, then that is when the next step comes. So you do entity resolution, where you try to form those same as links, so that the same node can be, we know that they are the same node, so they don't screw up our queries. The other one is finding incorrect links. So it turns out that extraction is imperfect, but once you have the graph, then there are certain machine learning techniques that are actually based on neural networks, but also probabilistic soft logic. There are a number of techniques that can allow you to predict when a link is wrong. So you can actually, there's a lot of cool machine learning that can tell you when the link is wrong. So they can also help you to predict relations other than same as. So imagine that there's some city that is the capital of a country, but it never got extracted from your raw data, and it might be that you have an incorrect link. Like let's say New York shows up a lot. So maybe the extraction has incorrectly concluded that New York is the capital of the US, right? And there's nowhere have we seen that Washington, DC is the capital of the US. So you can predict that this link is wrong and this link is missing. That's one example. You can also predict that New York City is the same as NYC and so on. That would be entity resolution. So all of that is knowledge graph completion, knowledge graph identification. There are multiple phrases for it. But that has to happen after construction. And then finally, when you have this graph, then you have to put it into some infrastructure. So if you remember, we started the conversation a little bit with graph database, but it's not the only option. But you have to pick some infrastructure, whether that's a Neo4j style graph database, whether it's an Elasticsearch kind of NoSQL, MongoDB, those kinds of things, whether if you have enough structure and enough attributes in your graph, maybe you can normalize it in some way and put it into an RDB. Again, that's very rare, but it has happened.
What is the size of the biggest known knowledge graph?
I think if I had to pick, I would say that the web data commons, which is based on the common crawl, right? It is like a proxy for the Google Knowledge Graph in the sense that what they have done is that they took the common crawl, and inside the common crawl we have schema.org. Schema.org is a markup language, so maybe your viewers are familiar with it, but it's basically a markup language. The Google Knowledge Graph relies very heavily on it as well. It's like putting markup, right? So you can actually put knowledge graph fragments into your web page in a very structured way. It's very noisy, but because it's in this very structured markup, you can extract the schema.org as a knowledge fragment from the HTML. And so the Web Data Commons has done that. So over the entire common crawl, they have extracted all the schema.org fragments. And it turns out that it's very fragmented, but it is a knowledge graph. And that I can tell you in compressed form is, I think, definitely more than 10 terabytes, if not much more, in compressed. I think when you decompress it, it starts approaching a petabyte. I'm just guessing, but I know it is many, many terabytes when it's decompressed. We never decompress the whole thing, but we know that it could very well be a petabyte. And so that tells us how big the Google Knowledge Graph must be, because the Google Knowledge Graph is probably bigger than that. I'm sure they have broader coverage than the Common Crawl, but it's also a lot cleaner. We have to remember that the Google Knowledge Graph is a lot cleaner. It's not because they want to give you a good search experience, so they're conservative. They don't just put everything in the Knowledge Graph. They are very conservative about what they do. But to answer your question, many, many terabytes, in practice, it is uncommon to deal with knowledge graphs of that size. We are usually dealing with gigabytes. That is the most common.
But at the large scale, you definitely need distributed computing infrastructure, right?
Yeah, you need a different infrastructure. I don't think that any one infrastructure will cut it. You have to design a custom infrastructure if you are doing at the terabyte scale. I mean, the first question is, how do we get this into, first of all, is it that big, right? Because the question might be that, okay, when you decompress the schema.org, you might get like, let's say 100 terabytes, suppose, right? But then it might be that it's not, when you actually remove a lot of the noisy stuff from there and you do the entity resolution, how you do that is another question, but you might be able to have some distributed computing that does that. Then the actual knowledge graph might be much smaller. It might become like several terabytes. It doesn't have to stay in memory. So then you can, I think that much data, you cannot put it into a graph database, in my view. Right? Again, the graph database people might say that, okay, we can support a 5 terabyte knowledge graph. I have not seen any cases like that with a graph database, nor have they reported on it. I do know that when it comes to the IR engines like Lucene and Elasticsearch and RDBs, they have supported that much data. So I would actually recommend the moment it gets above a certain size, the graph database is not your friend. And this is not against graph databases. I think they are great for a certain kind of querying and a certain kind of use case. If you have very sophisticated queries that are very well suited to graphs, if you have a certain data set size and your speed requirements are not super high, you don't want millisecond level responses, then go for a graph database. I'm very supportive, but they are not the, I would push back on the notion that if you have a knowledge graph, you must use a graph database and nothing else will work. No, not true.
So key word in knowledge graph is knowledge, right? So we know that machine learning, specifically deep learning, really is great for perception tasks, right? So
Yes.
simple, it's just a cat or a dog kind of in an image. So obviously, intelligence will require more than perception. So it seems logical that any AI system in the future will have to be backed by some kind of knowledge graph or knowledge base, right?
Yes, and I think they are. In a way, people are moving towards that. So, NLP is also a very big field where deep learning has had tremendous success. Machine translation, information extraction itself, has really benefited from word embeddings and, those kinds of things. Knowledge graphs themselves have been used a lot in machine learning because it turns out that you can apply a deep learning algorithm on the knowledge graph, and these things that I was talking about, the predicting the missing link, predicting the erroneous link, all of that you can use deep learning for. And the other thing is that the deep learning is also very good for recommendation. So for recommendation also deep learning has been applied. So I certainly think deep learning has limitations, but there are a number of tasks where there's lots of data.
What you're describing, deep learning is still
It's task specific.
relying on a knowledge graph, right? So
It's relying on data. I think it is
yeah, yeah.
not so much relying on knowledge graph, it is relying a lot on data. So as long as it has a lot of data, and it doesn't have to be labeled data. A lot of times for perception tasks, you're right that it should be labeled. Usually if you're trying to do, object recognition or some kind of task like that, you do need data. I mean, the data is available. We do have ImageNet and all these data sets. So, it's not that that's a barrier necessarily.
But Mayank, to be performant though, so if I have a bunch of pile of documents here that are not clean and not
Yes.
structured, not the knowledge information is not extracted, sure, I can probably use deep learning to answer my question, but it won't be as performant as if it were in a nice clean knowledge graph, right?
Well, to get the knowledge graph, you have to extract, right? So you need
Yeah. So
something for that.
you
Yes.
do all of that work, and then now you can hook up. So here's my knowledge, and here's my algorithm that will use that knowledge, right?
I think so. I think it can help you to get better features. If you can link
Yeah.
it to a good knowledge graph, there's no question that if you have another set of documents, then you can potentially do very good search and recommendation. But again, you have to use the right algorithm.
Right.
So anytime you have more data, I think no one would argue that more data that is relevant, and if it's clean, big data that is relevant and that can be linked to your task, that it would help performance. And, we have enough machinery now, algorithms now, that even if there's irrelevant data, we can still do very well. So it's, they can extract their own features and so on. So they're not so sensitive to the relevance of the data, even, I would say. Like,
And you used a word earlier in this conversation, reasoning,
yes,
right? So
a very interesting word.
so doesn't knowledge graphs aid in reasoning, right?
Knowledge graphs aid in reasoning. I think that is very true. There are the reasoning is a very broad phrase, so I can tell you that some people have very strong views about reasoning. And I'm not one of them. In fact, I have strong views in the sense that I don't have strong views. And I don't think that, like for example, in the semantic web and in the web community, they think that reasoning, and not just them, but also the logic community, the AI logic, the good old fashioned AI, all of those, rule-based community, planning community.
Yeah. So the old school AI, they had modules, right? So here's
They had
perception.
expert systems. Yeah, they were, I think that it,
Yeah. You have reasoning, planning, knowledge,
right.
perception,
They
right?
had all these different, they have the modules, and, they treated, I think the machine learning has really been about inference. The machine learning has been about prediction and inference more than reasoning. But it turns out that these are, I'm not an expert on the philosophical side of these things, but I do think that when we use the word reasoning, if we look at it as a human, right? So the human word reasoning, for a human, the reasoning is not rules and all of that. It turns out it's much more complicated than that. And we can't separate inference and reasoning and prediction and practice a lot of times. There's a lot more to it. Furthermore, the expert systems, the old-fashioned people, as you call them, they're not so old-fashioned anymore. I think that I want to say that they have really, they're doing some very exciting work now, where they are combining machine learning into their models. They are coming up with new theories, more scalable system. So there's a lot of exciting work happening over there also. But I do think that they have this view that you can explain reasoning through logic. I think that this strong view is that if you have logic, if you can express your axioms and your things through logic, then you can apply logical reasoning, deductive reasoning. I think the proper word is deductive reasoning. Their view of reasoning is very deductive. And for machine learning people, the reasoning is inductive. What that means is that you have data and labels, that you induce a model, and then after that you apply the model, and so that is inductive reasoning. You're not actually doing deduction. You're not applying axioms and rules. So they're two very different kinds of different modes of thinking. And in the human mind, both of them are applied. They are not. It's not like we don't do deductive reasoning. We do that. We plan, right? Like when we're trying to plan the day, you're trying to plan your career, right? There is some deduction involved. You're trying to plan for an exam or an important situation, or you're trying to find a route from one place to another. You are doing some deduction, but there's also a lot of induction, right? We're looking at past experience. It's never independent of past experience. So we are looking at past experience. When we do science, right, it is based a lot on induction. We look at data and we say, okay, I ran an experiment, I got this data. The data either falsifies or doesn't falsify my hypothesis. And that is induction, that is inductive reasoning. And then, so I am saying that both are important and that we have to find some way to get both into the model. And so far we haven't found that.
So
frontier.
So in closing, you have a new book coming out on knowledge graphs, fundamentals, techniques, and applications. So why do we need a new book on knowledge graphs?
I don't think we have a textbook. So we need a new book because there is no book. I think that if you look at the books that are there, they are extremely technical. And that means that it's not accessible to a lot of people. I mean, they tend to be research monographs. I myself, I published another book in 2019 by Springer, and that was kind of like that. That fell in that category, which had it was all about construction. So we talked about the knowledge graph construction. The book was titled Domain-Specific Knowledge Graph Construction. It was it was like a research brief, but more than 100 pages. It was a proper book. And there have been books like that. But there is nothing that takes you from the very beginning to the very end without requiring you to be this experienced researcher or data scientist, I mean, whatever you want to call it. It's something that really, imagine you're a graduate student, right? Or you're an undergraduate student, you're a student, you know something about computer science, you've done algorithms, you don't want to know what an algorithm is, you don't want to know what AI is, you have some experience, enough experience, or some knowledge, you can pick it up online if you want, but you want to know what a knowledge graph is, and you want to know how to build them, what kinds of things to use, you want to know where to go for reading, what are the software and resources, all of that, right? And so we cover that. There are 5 sections in the book. It's a proper textbook. It's going to be published by MIT Press. It's available for pre-order right now on Amazon. It comes out in March 2021. We are undergoing the last stages of editing at this point. So it's going to be a high quality work.
Is there, key question, will there be sample code?
There will not be sample code, but there will be exercises and there are software and resources. So one thing that we do is that almost every chapter, I think every chapter actually, has a software and resources section where we actually spend about a page to 2 pages, if not more, where we point you to all the different places you can go to for the code. So we tell you that, okay, here are, like information extraction, we actually tell you, here are the resources. So go to their webpage, right? And on those web pages, you will find a lot of documentation, tutorials, all that. So we've tried not to oversimplify the issue, because the truth is that we can give snippets of code, but it wouldn't help you because it's toy, right? It's a toy example. So rather than do that, where we take you through toy examples, what we do is we tell you what the thing is, so that if there's a chapter on, let's say, relation extraction, right? We actually show you, okay, how is this done? What is the state of the art, right? What is relation extraction? What are the challenges? What is the state of the art? What is the performance you can expect, right? What are the ontologies and so on? So we give you a very thorough, very rigorous. This is not something that is meant for software engineers necessarily, but for everyone. You read the chapter, there will be some advanced sections, of course, but you will now understand what relation extraction is, right? Once you reach the end of the chapter, over there, we have 3 special sections for everyone, right? Depending on who you are. There is a bibliographic notes, which is for the researcher. that will tell you it contains many citations. That is the stuff that we use when we wrote the chapter. So we will tell you, okay, if you're a researcher and you want to get into this, or you want to update yourself, then here are all the different things, right? If you're an engineer, a student, or you want to get up to date on projects, then there's software and resources. That also, and anyone can go for all the 3 sections or none. The software and resources contains everything that you need to know. These are the top packages. Here are some industry packages. They may not be available. These are the things where you can go. Here's the website, right? You can go to them. They have tutorials. They have this. They have that. We tell you everything. Then after that, they have the exercises. Now, in the last section of the book, where we go more into applications, we actually give you proper exercises. We tell you that, what if you had to do this project? Imagine you're part of a consulting team and you had to solve this problem. How would you do it? What are the things you would apply? Can you draw up a design document? All of that. In some of the earlier sections, the questions are a mix of trying to code something, trying to solve a conceptual question, but we do have exercises in the book. And we think those are very important. I mean, if you feel like you understand the material, then you should be able to solve the exercises, or at least be comfortable with them.
So, so final question to close. So our listeners are now familiar with all of these academic conferences in machine learning and NLP. So
Yes.
where do knowledge graph people gather?
Oh, that is such a great question. I wish I could say there was one conference, but I think it's actually a strength of the field that it shows up in multiple conferences and communities. So I'll just give you some brief examples.
Yeah.
Certainly the International Semantic Web Conference, ISWC, I would say that is the go-to place if you want to learn a lot about knowledge graphs, because it is, the RDF, I remember you mentioned that came out of that community, and a lot of knowledge graphs that is a proper model. The RDF and RDFS, all of these are proper ways to actually represent the knowledge graph. So that community is important. And in fact, we go there pretty much every year. I mean, this year we have a tutorial on common sense knowledge graphs, which is a super important area. So that I think is one conference. And related to that, smaller conferences in the semantic web are the ESWC, which tends to be in Europe every year, and that one is also very good, but it's a little bit, has a narrower focus and is more semantic. There's also KCAP. I was the general chair for KCAP last year, which is a knowledge capture conference. So that is another one. But the ISWC is the top, that's the one where if you want the semantic website. If you want NLP related, so they have usually a lot of work on coreference resolution, information extraction, word embeddings. All of these are very important in the knowledge graph community. Then you should go to ACL, or EM NLP has become very big, very good. Those are 2 top examples. If you're interested in recommendation systems and in data mining, right, then there are 2 very good conferences. One is KDD. So KDD is the top data mining conference. In fact, just last month, towards the end of August, we did a workshop in KDD. It just ended. We did a workshop in KDD on knowledge graphs and e-commerce. So if you go to my webpage and to our group webpage, you'll see that there is a workshop for knowledge graphs and e-commerce where we had, I co-organized it with researchers and senior researchers from Amazon, from LinkedIn, from the Home Depot. And we had speakers from CMU, from the Amazon product, Grafting, Luna, Dong, very well known. So all of those, so the KDD is a very good example if you're more interested in applications and the embeddings of graphs, working with graphs, link prediction, all of that. If you're interested in social networks, then Asonam is a very good example. They have less on knowledge graph, much more on the social networks and networks, right? And then finally, if you're very interested in the machine learning, like the hardcore machine learning algorithms, then I think that NeurIPS and ICML are very good, but they are hardcore machine learning, so there may only be a very small fraction of knowledge graph. You have to look for them. I mean, you may not even see it in any given year, but usually there's a small fraction, like from Facebook research and other top places. Some of the top researchers try to aim for NeurIPS and ICML. They don't, or ICLR sometimes, but it's that NeurIPS would be the choice. And then finally, I think SIG-IR deserves a mention. If you're interested in information retrieval recommendations, SIG-IR is a top conference, especially for recommendations. So they do use some knowledge graph. I think if you have a search paper, top search paper, you would usually see it in SIG-IR. And then there's Triple AI. It's coming up in February, and New York's will be in December, I believe. Triple AI is in February. Both will be virtual this year. But Triple AI, just like New York's and ICML, it's not core machine learning, but it's all of AI. But a big part of that now is machine learning. And they do have a knowledge graph and knowledge base and NLP track. So I think that if you're looking for like a one-size-fits-all conference where you want knowledge graphs, you want NLP, you want data mining, all of that, then I think Triple AI, New Reps, ICML, those are the places to be at. But if you have domain-specific needs, then there's some of the other choices that I just pointed out are the ones to go. So, I mean, I'm not trying to give a long, rambling answer. The truth is that all of these have work in Knowledge Graph, and I have published in many of these myself. So I'm living proof. I'm not just speaking out of turn. That you and it's. I think it's a great thing. I think it's a great thing that all of these different conferences, the Knowledge Graph plays a role in all of them. So that shows you that it is involved. It's like a central point. If you work with knowledge graphs, you have a chance to work with many of these different communities in some capacity.
And with that, thank you, Mayank.
Thank you.